So, so let's go ahead. So, let's see. So first, let me go ahead and preferences. Fira Mono 18 or Fira Mono, and then we're going to go up to 24. Yeah, there we go, 24. All right, so this is a dictionary file. If you're using a computer, most of your computer probably has something that's like a spell check function at the moment. Let's see. So your computer has something like a spell check function on it, and the way it knows what words are in the English language is that it has a dictionary file. Now, I've already uploaded this file for you. It is over here under the Files tab. Give me 1 second. Oh, come on. So, also computers have a hard time dealing with things that are like megabytes in size and multiple pages like this, which is pretty funny, actually. So if you click over, so if you go to your Canvas website and click, and you'll notice there's a new tab under assignments called Files, which has basically all the files we've uploaded so far. You'll find what the things we have over here. And the dictionary.txt is just basically I think it's just got a dictionary of all the words in the English language, and I do mean all of them, so, or the vast majority of them. And it's a file. Now, the thing about file reading in Python and any programming language, first off, in Python it's easy. In other programming languages, they make it a bit difficult. But the most important thing is that when we create a new, so let me go ahead and boot up idle to just kind of show you. When we want to work with a file, we got to make sure that the Python file that we want to read the file is going to be in the same folder as the file we want to read. So in other words, here I have to save as, and I've got to put it into the same directory where that file is, which for me is classroom ITP. And then I'll say this is reading example. Okay, so notice that it is that this file I have created, right? If we go back over here, is in the same folder as the text file that I've created. So it's a Python file. Now to read files, reading a file is super easy in Python. It's one of the things that actually made me fall in love with Python because it actually worked the way I thought it would, which is incredible. Like normally it's like in other languages I have to like create buffered readers and all sorts of stuff, but here it was fairly easy. First off, I'll say the text is equal to, or rather I'll say text file is equal to open. Now I don't want to use the word, now normally I might use the word like file. Actually I can use the word file, yeah. File is equal to open, and then all these kind of things just come up when I say open. But basically you want to put the name of the text file you'd like to open, which is dictionary.txt. Now this is what we call a path. Now when you don't give it anything else but a name, it's just going to assume it's in the same place. We'll learn more about paths later. But right now we can assume this is in the same place. And then we give it a second argument, a string that contains R. There's basically two options. We have here. An R for read, for when we want to read a file that's there, and a W for write, which is when we want to overwrite or create a new file. Obviously, we would probably, since this is file reading, not file writing, we'd want to read the file. Okay, so that's about it to open the file. Run it, and it does nothing, of course, because that's all it did was just open the file up. So how do I actually go through and print stuff? It's actually, again, ridiculously easy. For line in file, and line can be anything, but print line. And that's it. That's all you have to do to read a file in Python. Now notice that basically we have an extra space in between each of these guys. Now this is because each line in the file, if we go through each of these strings that are in the file, let me open it up again, the dictionary file. Oh, and notice that it also takes a while to print out because computers are very slow at printing. So we're only through the A's. So I'll just go ahead and terminate this guy. Yes, I want to kill it. Okay. We've got all these things, and the reason it's giving us an extra new line is because at the end of because it goes A, B, O, U, T, and then to get to the next line, it has a new line in the file, even though you can't see it. Let's see if I can actually see it. View, tools. Nope. Preferences. Highlight current line, yeah, definitely. Display line numbers, sure, that's useful for coding. Editor, enable automatic indentation, nah. Okay, so it can't really show that. So let me open it in a different text, in my preferred text editor, which is Geany. And now if I say edit preferences to Geany, I can tell it to display white space and line endings. Right? And these marks are basically saying that this is the enter key being hit over here to go on to the next line. So that's why when we were printing out this file, we have got a space in it. So what we're going to do is we're going to do a little trick here. I think it's line is equal to line.trim. I think it's trim. Let's see. I know that's trim in Java. Okay, there's no attribute trim. Let's go ahead. What would let's see. Maybe slicing off the last character would work. So line is equal to line up to everything but the last character. There we go. Because the last character is a new line. And now we're printing out, Oh, I remember what I was looking for. Now I remember what it's called. Line.strip. What strip does is that it removes any beginning and trailing white space from strings. So, for example, let's go ahead and kill this again. So let me go, come on, debug, options, Control Z. Can I Control Z? There we go. Control C to kill stuff, or kill a program that's running. So if we go over here, if I do, for instance, a bunch of spaces over here, this is a line, space, 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 and I call dot strip on it. That will strip any beginning or preceding white space, whatever it is. Doesn't matter if it's a tab or whatever, right? Notice that it just clipped off all the stuff before all the letters and all the stuff after the letters. Any white space, including new lines. So that's useful. So that's all you have to do to read a file, right? It's actually fairly interesting. So printing this out now it doesn't actually take that long to actually read a file if all we're doing is just simply reading the stuff, right? So here I'll just simply strip the line. If we're not printing anything out, it doesn't take too long to actually run this. Done. So here I just commented out the part where we print it. Run it, boom, done. Printing takes a long time to do. Oddly enough, especially in idle. Idle's just very slow at printing for some reason. But still I like it, despite all of its flaws. So for line in file, strip it, it was done. So let's go ahead and do something a bit more interesting. How about figuring out how many bloody words there are in that file, right? since one line is a word, right? Let's go ahead and create a count is equal to 0. For line in file, count plus equals 1, right? For every line we read, increment it by 1, right? Remember, every single line contains one word in this dictionary file, right? And obviously, I could kind of just scroll down here and figure that out, but I mean, it's much more, it's satisfying to be able to do it this way, and now we can just print out count. And again, for those of you who came in a bit late, for this to work, you have to have the file, which you can get from under files in Canvas. It's dictionary.txt. Okay, and then the other thing we can do is, and then the other thing you have to do is that you have to put the dictionary file, the text file, exactly where the file that you're using to code with is. Otherwise, it can't find it, right? Like, for example, if I tried to call this dictionary 2 and read dictionary 2, there is no dictionary 2, so you're going to get an error like this. So it's got to be in the same folder. You got to actually give it the name, and it cares about the name. All right. So let's go ahead and do something that's a bit relevant to our homework a bit. So let's practice a bit on slices. So an interesting question I like to ask when we introduce regular expressions, but it's perfectly good here, is if we've got this file of the English language, I can answer some interesting questions that I've had idling thoughts about, such as, are there more words that end in ing or ion? Right? So I don't know, but we've got a dictionary file, so we can count out. So let's go ahead and let's go ahead and code that up. Do more words end with ing or ion? So I'm going to create ing is equal to 0, ion is equal to 0. And what I need to do is find out for each of these words that we create, does it end with ing or ion, right? That makes sense to everybody? Going to look at each word one at a time, figure out if it ends with ing or ion. Okay? So what I'll do is that first thing I'll do is, like I was doing earlier, I'll strip the file, or the line. Line is equal to line.strip. It's not sufficient to just do line.strip by itself, because while lists can be changed, strings are immutable, meaning that if I do line.strip, that doesn't change line. That creates an entirely new string, right? It creates an entirely new string based off of line. So line is equal to line.strip. Create a new line with the white space stripped off and store it in line. Okay, and now we have to ask ourselves, how do I know if it ends with ing? Now first off, does it have a line dot ends with? Maybe, but we can just use slicing to our advantage, which is that we can say if line, the last three letters of it, so we need a slice for the last three letters, is equal to ing, right? We'll figure out that slicing in a bit. ing, ion. So if line, whatever that slice is equal to ing, if the last three letters are ing, then we just increase ing by 1. If line in that same slice, if the last three letters are equal to ion plus equals 1. So how do I get the last three letters? Well, I want to start from the third to last letter, and then I want to go up until the end. So -1 gets the last letter, -2 gets the second to last, -3 gets the third last, right, if we're going backwards. So -3 to the end gets the third to last. Remember, that's short for len of line -3. So this gets us the third to last one. And then what we can do is that we can also just make it a bit slower and print out line whenever we hit an ing word, and we'll see. Oh, 0, 0, that apparently didn't work. So open dictionary, ing, for line and file, line.strip if, oh, what's my issue? Anyone? It's not an issue with my code. My code's actually not gonna, there's nothing wrong with my code per se. Yep. So this is file of dictionary words is completely capitalized. So I have to make everything lowercase, or I have to change ing over here. There we go. There's a lot of words with ing. Capsizing, clogging, condensing, copying, cultivating, on escaping, extending, right, formalizing, graduating, gothicizing. Interesting. So there's a lot of words with that. Again, printing makes this go much slower. Boom. We got 3,702 words versus 1,095 words. So more words ended in IOG than ION by a fair margin. So that's our boring example. Most of the time, though, you aren't reading a text file. Text files are fairly useful. Most of the time, what you're dealing with are some, what we use a lot of, most of the time when you get data, when you find data, it's stored in an Excel file. Now, we'll learn about Excel files later on. That's not covered in your book, but it's covered in one of the supplemental materials I do provide in syllabus. We'll talk about that later. But most Excel files can export their spreadsheets into something called a CSV file. Now, a CSV file is what we call a comma-separated value file. Now, I was looking for trying to find a non-boring data set. And so I asked, as I was discussing with my wife in the car, I need to find a non-boring data set, and she suggested, well, why not Pokemon? That's not boring. And I tend to agree with her. So I kindly found, and I'm not sure who did this, an entire data set of basically the stats of various, basically all the current Pokemon out in there. Actually, I'm not sure. I think possibly from... It goes up to Gen 6. Yeah, Gen 6. So anyway, what is this? This is a comma-separated value file. So this is a comma-separated value file. Now if you've never played Pokemon before, A, you've missed out, and B, that doesn't really matter for this. But this is a list of all the different creatures that you can catch in that game. Now, notice that this is what we call a comma-separated value file, where basically all the values are separated by commas, right? For Pokemon number 1, that's Bulbasaur, then it's grass, poison, then a bunch of numbers over here. Okay, now if we were to actually double-click on this file, it's a CSV file. And by default, most CSV files get opened by your spreadsheet thing, be it Excel or LibreOffice or something like that. And it knows to separate things out by commas. So it's just it's a text-based way that's easy for programs to work with. Let me go ahead and increase the font size to something legible, right? Make you squint your eyes right over here. So let's go ahead. Oops, that was not, okay. Whatever, that works out just fine. So as you can see, it imports it just fine, right? This is a file with a bunch of stuff over here. Okay, and as we go through, we're going to need to find a bunch. We'll see. Let's see. There's a bunch of stuff. I think. Oh, that it had some trouble reading for some reason. Oh, it's saying it's a number, but it's not able to render it because there's not enough space. So that's no worries. Okay. So so this is a comma-separated value file, and typically we read a lot of things that are comma-separated value files. There are two types of files that are stored on your computer. First off, comma-separated value files are text files, even though it doesn't end with the .txt. Python is a text file, and what I mean is that I can open it up in a text editor like idle or something that's really meant for just displaying text, like Notepad, right? Or something similar, and it's able to read it, okay? On the other hand, let's go ahead and take a look at this PDF file that I've used a couple times, right? This is a PDF file. It has text on it, but it is not a text file. It is what we call a binary file because, have you ever tried copying and pasting from a PDF? It's terrible, ain't it? Right? This is because it's not really meant for, it's meant to be kind of just read by the computer and rendered by the computer. So if we actually were to open this up in, well, I'll go ahead and open in Terminal over here, and I'll use Vim, which is a text editor that works in the terminal, to open combined minutes.pdf. All right, there's some stuff here. Type, pages, count, 40, kids. So PDFs apparently have parents and have kids. Great. Oh, okay. So this looks like code. So technically we can read that, I guess, maybe. Let's go ahead and it says, oh, I'm 6% of the way through the file. Okay. Oh, so here it says subtype image stream. This is a binary file. We can't read a binary file without an application. So .doc files, .pdf files, those are binary files, right? It's the reason why you're able to basically send you send somebody a document and it might be corrupted for some reason because you sent them a PDF that you renamed as a doc file in the hopes that you would get a 3-hour extension while they haven't noticed that you have a corrupted file. I don't recommend doing that, by the way. And I haven't done that, but I've heard people have. But fortunately, I deal with text files, which means I can open it up and see what's there. And as you can see, it's a bunch of gibberish right here. Tons of gibberish. So we don't deal with reading binary files without like a special library or something, like Py2PDF or something like that. Images are binary files, but basically, can you open it up and read it? Like literally, just sit down and read it, and understand it. Then it's a PDF. Then that's a regular file, text file. Otherwise, it's a binary file. And the advantage of CSV files over Excel files is that CSV files can be manipulated in a text editor and by a basic programming language, whereas an Excel file needs libraries or possibly to be worked in Excel, right? So here, we're going to be able to do some calculations outside of Excel using this. So let's go. So let me go ahead and explain. But let me go ahead and just again prove the point to you. I can read this fairly easily. So Pokemon, right? And by the way, the capital P matters here. This should be much easier to quick print out since there's only like 800 lines. So 4-line in file, line dot strip. Actually, I'll make a new file. Whoops. Yeah, I'm just going to cancel. Yep. Nope, don't want to save it. So I'll work in here for right now. So, new file. And it will go in and it's got to go in the same place as the Pokemon.csv. Reading Pokemon.py, make it a Python file. Great. Okay, and I don't need to view my white space anymore. Don't show line endings, right? But do show white space because that might be useful. Okay, so file is equal to, so file is, I typically don't use that because it's a protected word. Python likes it. So I'm just going to call it text is equal to open Pokemon.csv, right? Because it's the CSV, because that's what it's called. This is part of the name, by the way. The only thing that the extension is useful for, the only purpose it serves is that when you double click on is that it's kind of integrated that basically that the dot whatever it is tells your computer what program to use to open it, That's really the purpose of it is. You can open anything in any program. Your computer might just not, that program might not like it. Like I could open an MP3 in a text editor. I just don't expect to get any music out of it. So now Pokemon.csv, read only. And now we are going to say for line in text. It's super easy to iterate through these things. Print line. And as you can see, it prints out very easily, right? Okay. So let's go ahead and print out actually line.strip at the moment so that we can see that, right? So what am I actually looking at here with all this stuff? Well, this first line explains it. I've got the Pokemon number. So Pokemon are classified by number, right? It's kind of their unique ID. Their name, which, you know, are often like really, which some are really interesting and some are just really bad puns or somebody thinking they're clever by calling, which Ekans is a snake Pokemon. It's snake spelled backwards. I know, and you might feel, and it took me years to realize that. Same with Arbok. It's Cobra spelled backwards, also a snake Pokemon. Anyway, Pokemon have type. We're not really going to look at the type of different Pokemon here. But basically there's like 17 types or something, 18 now? There's 18. 18 now. But we really don't really care about that because those are a bit more qualitative to work with. Instead, what we're going to look at are stats. So Pokemon have basically 6 stats. HP, hit points, how much damage you can take. Attack, how much damage you can deal. Defense is how much damage you can resist. So attack and defense get thrown into this nasty equation that basically calculates how much HP gets lost via an attack. These are for physical attacks. Special attack and special defense are for more like stuff like burning other people with fire. And speed, basically who gets to go first. Now these are what we call base stats, but basically they're a way to rank Pokemon based on their other stuff. And also total, which they've calculated for us, but I was going to go ahead and calculate that automatically, which is basically if we add these up all together, then what is their combined value of these stats? So it's 1, 2, 3, 4, 5, 6. Then there's 2 other things over here. Generation, which is basically, which we're not really going to necessarily use too much, but generation is basically going to be 1 through 6, which is basically when the game was produced, like how old that Pokemon is. So first gen Pokemon versus the 6th gen one. And the designs really change over time. They became a lot fluffier as time went on. And then legendary. Some Pokemon are like legendary Pokemon. So if we go down to 150 and 151, right, we see Mewtwo is a legendary Pokemon. So then these are like special Pokemon that are often banned from tournaments. I don't know why. We don't need to debate minutia of Pokemon right now. But anyway, so the question is, like, what I'd like to know kind of here is, right now, if I can use this file to figure out which Pokemon has the highest HP. Right? Which one is going to be basically able to take the most damage. That's kind of a thing we can use and sort with this file. So the first thing we'd have to do, though, is being able to actually read this file and turn it into something that's manageable. So let's try. So the first thing we can do, right, is for each line, right, is equal to line. Each line contains one Pokemon. Line.strip. Okay? The next thing we want to do is use a function that we've talked about but not really used. And that means, by the way, that on Tuesday we will finally do that split and join quiz because we're finally going to be using split and join here, okay, in a way that makes sense. So here, so let's go ahead and I will print out, this is what we've got when we do line like this. Now I'm going to show you what happens when I call line.split on these guys. Specifically, what I'm going to say is that I'm going to line dot is equal to line dot split on a comma. So you define what you're going to split on. And what that will do is that will turn line into a list, or split line up into a list of a bunch of strings that have been separated by commas, right? It's comma separated values. So now notice that we've got a bunch of lists over here. 618, Stunfisk, ground, electric. Then we've got the different fields here. So now we can go through and iterate through all those specific fields rather than trying to figure out what in the world are we going to do. So first off, though, what we can do is that this guy, we'll have to take care of this thing, the header. I don't want to delete the header. It's useful. But we'll have to take care of it and have a special case for it. So what I need to do is find out which Pokemon has the highest HP. Now, let's go through this. So this is index 0. This is index 1, 2, 3, 4. So HP is index 5. So what I could do is that if I just print out index 5, is this making sense to everybody so far? Just print out index 5. Boom. These are all the values. HP. We could also print out, let's see, line, it was number first, and then it was name. So we can do line 1 and line 5. By the way, I haven't worked with this file before. I literally harvested this file this morning. So, and by harvest, I mean I Googled it and found, I Googled Pokemon CSV file and clicked on links until I found one that was appropriate. So there we go. We've got their stats over here, or we've got their name, and we've got the HP ratings of each of these Pokemon. So, what we need to do though is a couple of things. First off, we did notice this. It was apparent when we were printing this, by the way, when we were printing the whole line, but not necessarily apparent right now. But every field in here is a string. So if we want to do comparison to see which one's biggest and smallest, we'll need to turn this into an integer, right? So let's go ahead and do this. Name is equal to line 1, right? I'm going to just rewrite this slightly. Name is equal to line 1. HP is equal to line 5. Okay? HP is equal to line 5. And then I'm just going to print out name and HP. So now, again, it's going to come out with the exact same thing. All I did is stored line 1 and line 5 in variables, right, to make it easier to read. But also HP should be converted into an integer because it's a number. Invalid integer with base 10, HP. Oh, right. I'm trying to convert HP into the string HP, right? What's the first line? Remember, the first line of this program, of this file, has all this stuff in here. So we kind of need to have a way to skip this first line. Well, that's not too bad. What we can do is use a special word, continue, which is what we do here is that basically say, hey, if line 0 equals the number, right? Print, or rather not, don't print anything out. We're just going to continue, which means we're done with this current line. Go on to the next line. That's all that means. Don't bother doing anything below this. Let's see if that works. And that worked. So now we're just printing out all that stuff, and now this is an integer. So now that's an integer, we can do comparisons. Best HP is equal to, let's go with -1 for right now, right? Because everything is going to be higher than -1. And then we'll do let's go with toughest is equal to -1 as well. or equal to empty string. So what we are going to do is that we're going to go through, find the Pokemon with the highest HP. And now we grab these HPs, so what we're going to do is that we will say if the current HP is greater than the best HP, so in other words, if we're looking at a Pokemon and the HP of that Pokemon is better than the best HP we've found so far, then best HP is equal to that HP we found, and the new toughest Pokemon is now that Pokemon. Make sense? This is a common form that we're going to use a lot, which is simply finding the maximum, finding the biggest or smallest. So we keep track of the biggest thing we've found so far, and we're going to replace it as we go through. Right? Go through every line, strip it, split it up into the separate fields. If that first field is it says number, then we know we're at our first line, and we don't want to read that first line, so we're going to skip it. Then we get the name, we get the number of HP. If that HP is better than the best HP, print it out. And so now, what we can do is that we can print out best HP, the toughest Pokemon who has the best HP. Which is Blissey to nobody's surprise, which if you know Pokemon. Now, which for reference for those of you who don't know, the Pokemon with the most HP is this thing. Yeah, it's the pink one. It's the although last I checked, it does have extremely horrendous defense. So it takes a lot of damage. But anyway, so we can also do that for basically for the Pokemon with the strongest, with the highest attack rating. Strongest is equal to blank. Best ATK for attack, right? It was HP then attack, right? So we can get, and that doesn't really require us to do much of anything different here. We just have another field. ATK is equal to, would probably behoove me to actually set this variable to something. Again, -1. So grab the current Pokemon's attack, that's line 6, and that's going to be a string as well. So remember, whenever we're dealing with file reading, it's all going to be strings. So we grab it, and then we go ahead and grab the strongest Pokemon with the best attack, which might be attack. So let's see. And so, right, if ATK is greater than, I was working in Java earlier. You don't need these parentheses. So if ATK is better than best attack, then same thing over here. Best attack is equal to attack. Strongest is equal to that name. So now we can print out the toughest Pokemon, and then we can print out strongest Pokemon, which is Mega Mewtwo, which honestly doesn't seem fair if you know your Pokemon, because Mega Mewtwo is legendary, meaning basically it's banned in most tournaments. So I can't actually use it if I want to go to a tournament. So maybe I'll add another field here, right? They had a field here saying, if it's legendary, which is a Boolean value, right? It's either true or false. So if it's legendary, I'm going to continue on that one as well. I'm just going to make this more and more complicated, or more and more complex, or add little more fields. So if line 0 is equal to that, or, so what is that one? I don't care. I don't want to count. It's the last one. So I'll just simply say if line -1, right? Last one. Love Python like that. So if line -1, and we turn it into a Boolean, bool turns something into a Boolean. Remember, it's a string. Equals true. I'm going to continue. I'm going to skip past any legendary Pokemon because honestly, that's just cheating. -1, -1. Ooh, maybe. Okay, so if the line starts with number or Boolean line -1 equals true, print skip. What happened there? Did I accidentally break it? Yep, accidentally broke it. So what's going on there? So line -1, legendary, false. So what is it? False, true. Oh. So, that wasn't as smart as I thought it was going to be. Okay, so quick thing so Stephen Colbert was known for a lot of things, and the first thing was like the word that he introduced in the first episode of the Colbert Report, which is truthiness, which has been adapted by Python. So we all know, actually, let me create a new file to show this to you because it's kind of important to understand, so you guys understand why that wasn't working at all. Okay, so let's go ahead. I'm making a new file. This one doesn't require any file reading whatsoever. ITP, and I'm just going to call this truthy. Okay. .py. Okay, so if true, right? Print hello. Else, or actually, I'll just print true. Else, print false. This is going to be very boring, but right. So if it's true, print out true. If it's false, print out false. But you can have other things besides a Boolean inside of an if statement. In fact, in the ancient programming language of C, built in the dark ages of the 1970s, where there was actually no Boolean data type built in. Instead, you were expected to use ones and zeros, specifically 1 for true and 0 for false, or more specifically, 0 for false and anything but a 0 for true. And that's been carried over kind of into Python. So for instance, if 1 true, 1 is truthy, right? It is a truthy value. It's not true, but it's truthy. And 0 is falsy. Also, anything that basically represents an absence of things is falsy, right? The empty string is false, but any other string is true, right? This is kind of the 0 value for a string, right, if you think about it, right? You add this to any string, you get the same string. You add 0 to any integer, you get the same integer, right? Let's see, what about an empty list? Does that work? False. What about a list with some values in it? 13, 13. True. What about a list with 2 falses in it? Well, it's got values in it now, so it's truthy, right? Basically, it's got to be a non-zero value. So, now, what does that mean for the Boolean expression for bool over here? Well, bool of any string, it gives me, this asks for the truthiness of that value. Doesn't give me doesn't turn a string into a Boolean. It gives me the truthiness of that value. So the truthiness of the string false is true because it's a string. So that's why that wasn't working. So, because it wasn't a non-zero value. So, so now I just actually have to check, wait, So I'm actually going to have to check it. If line 0 is equal to the string true, or line -1 is equal to true, then we skipped less guys. So Mega Heracross, which is a very strong bug Pokemon, that has a 255. Now, 255 also is a very interesting value. It's a very specific value to see it twice. The Pokemon with the highest. Why are we scaling? Why are Pokemon stats scaled from 0 to 250? Yes.
Oh, wait, no.
Why are Pokemon stats scaled from 0 to 255? Any suggestions? What's significant about 255? Yes. It's the same reason as RGB, yeah.
It's the highest value that you can have in hexadecimal value number.
Yeah, it's the highest value a byte can store, or 1 byte, if you're not using negatives. So 0 to 255. It's actually quite interesting for these values. Typically, you'd be storing things like that in a byte. It's actually a very interesting story about the video game Civilization. Who here has played Sid Meier's Civilization, by the way? Yeah, plenty of. Yes, Gandhi, of course. Everybody knows about Gandhi. Well-known man of peace. Unless you are a Civilization player, in which you know that he will nuke you 9 ways out the door. Now, this is because of an Easter egg that was derived from a bug in the second Civilization game. So Civilization, you play as a world leader, as a country, and try to take that country to basically it's to the top. You can win by domination victory, where basically you conquer all the other countries, by a diplomatic victory, by basically having everybody vote for you as world leader. You can also win by, science victory, which typically means you launch an expedition to Alpha Centauri or something like that. So Civilization, though, now you could play as India, because India is a very large country, very important country. But with Gandhi, he, of course, was the obvious choice. Now, in Civilization 2, though, what you would notice is that, each of these leaders have their traits, right? If you're next to Attila the Hun, you know that you better be building defenses, because Attila the Hun is about to start coming, and sending his warriors to raid you. Same thing with the Khans, right? He's going to probably send a bunch of horsemen. But Gandhi, you don't really need to worry about. He's peaceful. He's most likely be cooperative with you. Except in Civilization 2, where this message would, you'd get something along this line. Very well, we will mobilize our armies for war. You will pay for your foolish pride. Or, as you can see, there's quite a number of memes of this from Civilization 2. And it was from a bug that was in there about nuclear weapons. Right, this is possibly the most common thing. Greetings from Mahatma Gandhi, ruler and king of the Indians. Our words are back with nuclear weapons. Him warning you that basically he's. So this is the result of a bug in Civilization 2. Now, the values for each of the AIs, the basic AIs of the computers of the computer civilizations were basically set. So there was a value and that was given a value of 1 to 10. Okay. Values were 1 to 10. So and they would be aggressive, and they'd be stored in a single byte, which has a maximum value of 255, as we've just discussed. So Gandhi, on that scale, had an aggressiveness rating of 0. So what would happen, though, is that, of course, Gandhi would when the ideal of democracy would become available, he would adopt democracy. And what happens in Civ 2 is that democracy reduces the aggressiveness rating of a civilization by 1. Gandhi's already at 0. What happens? Well, in that case, we basically get an overflow. So basically, we wrap back around to 255. So Gandhi now has an aggressiveness rating of 255 out of 10. Which is why he starts building nukes and tanks and starts being really, really hostile. So as a result, they've kind of kept that as an Easter egg for a lot of the Civilization games. But anyway, This is not so much of an issue when you've got when you're in you know, in Python, because you can't overflow in Python, but in other programming languages you can totally overflow. Like here, for instance, if I were to do Java, right, where you define things with integers and stuff, right, the maximum value for an integer, which is 32 bits, is around 2 billion. So if I take 2 billion, so this is what, hundreds, that's 20 million, so that's 2 billion. Right, if I go ahead and add 500 million to this, we'll see that the result isn't what you'd expect because of an overflow error, right? Basically, it goes up to 32 and goes around. You'll learn about worrying about this when you program in Java. This is not something you have to worry about in Python. Python says that's stupid. That's not intentional at all. If you want it to be intentional, then use modular arithmetic. That's when we use wraparound values. So anyway, that is also so, but it's very common for stats to be in video games as a result to be out of 255. That was an article, What Causes Gandhi's Bloodlust in Civilization. So, anyway, we can now back to our Pokemon. Let's go ahead and figure out maybe who has yes. Best HP? Oh, yes.
Oh, yeah, that's why it was 255.
It's ATK.
That's why I noticed.
ATK. Okay, so.
His attack says not 255. That would be insane.
Okay, so best attack is 185. There we go. My bad. Thank you. So now now let's go ahead and figure out who maybe is the strongest non-legendary Pokemon. Okay? And by strongest, let's go ahead and define strongest rather than trying to figure out who has the best HP and all that jazz. Let's figure out who has the best total combined stats, best average stats. So what we're going to do is that we're going to add all these 6 stats together and divide by 6, right? There's 6 stats, so we're going to add them together, divide by 6. So what we'll do is that we'll simply say the best is equal to this Pokemon. And that best stats is equal to -1. Okay, so we go through, keep this. We're going to exclude legendary Pokemon. We're going to grab the name. So, and so let's go ahead and just copy this over here, right? So what we're going to do over here is that we're going to expand this a bit. Once we go for the best, we're going to ask ourselves, well, is there a way we can go for the top 5 or something like that? Right? That's a bit trickier. So attack, defense. Oh, can't use that, right? That's define. So we're going to call it DFN. SPA for special attack. Let's see. SPN for special defense, because we were going to use SPD for speed. Don't know what the official stat. And those are all next to each other. Int, line, 7, and then just nice copy pasting here. 8, 9, because they're all next to each other if you remember. Right, it was HP, attack, defense, special attack, special defense. Oh, let's call it S. Special defense and speed. There we go, whatever it's called. And so now what we're going to do is we're going to add that up together. Total is equal to, let's go ahead and compute best average as well. We'll just do total is equal to HP plus attack plus defense plus special attack plus special defense plus speed. Oh, yep, thank you. 5, 6, 7, 8, 9, 10. 10. How embarrassing. Those are the kinds of errors that are very easy to make, by the way. And I make them, so don't feel bad when you make them. Just go, okay, I made this mistake again. Now you'll know to look at it for next time. Also, and so now the average is equal to all that divided is equal to total divided by 6, right? Added 6 numbers, divide by 6 to get the average. And so if average is greater than best stats, best is equal to name, and then best stats is equal to average. So again, so let's go ahead and print out best and best stats. And that would be Mega Tyranitar, which is this like Tyrannosaurus rock Pokemon, who has an average stat of 116.6. So that's pretty cool that we can do that. We can ask ourselves, does that differ for the total, right? If we switch this to total pretty quickly, does that give us a difference? Nope, still Mega Tyranitar with an average stat with combined stat total of 700. So now okay, so that's a whole lot of stuff. What if you wanted to find out if it was a Pokemon of a certain type, though, right? What if you were interested with the strongest normal type Pokemon or the strongest dragon type, right? So we can modify this as well to say, so we can modify this, or we can put one separate down here, which is, okay, if the Pokemon's type is not dragon, right? There's a lot of different types over here, and Pokemon can have up to 2 types. So we just want to find the best dragon Pokemon, or the best, strongest dragon Pokemon. So we'll go ahead and check if type 1 and type 2 don't contain dragon, right? So what field was that, by the way? That was 0, 1, 2, 3. So 2 and 3. If line 2 is not equal to dragon and line 3 is not equal to dragon. So let's think about that for a sec to make sure that why am I using the and not equals? So for instance, let's go ahead and check this first Pokemon, which is a grass poison type. So let's see. If type 1 is not equal to dragon, so that's false, so we're going to skip it. Okay, let's go ahead and look. And let's go ahead and look at that. But what about for this guy? Right, we've got Charizard, which is a fire dragon. Will that work for it? Line 2 is not equal to dragon. So that's true. And line 3 is not equal to dragon. That's false. So it's going to skip this. So it's going to skip this block because it's a true and a false. The or would actually get me in trouble here. So let's go ahead and see. And it says Salamence, which is a salamander kind of thingy. Not the kind of salamander, the cute kind. The salamander as in the classical draconic salamander. Yep. Salamander. That's a term for that's an old term for dragon. So, there's a lot of fun things you can kind of do with these things. But like I said, it's a bit tricky if you want to get like the top 5. If you want to get like the top 5 or something like that. Because question is, how would you store it? It's actually a real pain. And that will get us into something called dictionaries at some point. But for right now, I feel like I want to work on some more kind of splitting of data sets and that kind of stuff. Let's see. So this was fairly straightforward to work with, right? The big thing is that with comma separated values, which we'll get a lot of, you typically just split up a lot of numbers and the like. All right, let's go ahead and get another text file. So now, so I'm going to go ahead and download the complete works of William Shakespeare. Now, when typically people say they're going to download a book, right, or something like that, you think, piracy am I going to get in trouble for that? Well, the question is, who makes money when you basically buy a book, like when you buy a copy of Romeo and Juliet at the bookstore? Who makes money from that? The publisher, whoever decided to publish the book. And who has the right to print that book? Anybody who puts it in between binding for any work that's out of copyright, right? So copyright basically in the United States is essentially determined by the Walt Disney Company. You think I'm kidding, but essentially they lobby Congress whenever Mickey Mouse will enter public domain. So currently, it's the law in the United States is after the creator of the work has died, and 75 years after that. That's when the thing enters public domain. So it's actually quite harmful. I'm actually then you can get one of my personal little political pet peeves is that it should be much shorter, and that's but. And different countries think differently. So for instance, Gutenberg, Australia, has the stuff that would be out of copyright in Australia, right? Like for instance, Animal Farm by George Orwell, right? And that was let's see, Animal Farm, right? Text file over here. And you could and you can read Animal Farm free. But as far as the complete works of William Shakespeare, I really like it. This started as kind of a Project Gutenberg, named after the Gutenberg press, right? First really popular printing press. I looked for a long thing. Let's go for old Bill. So Shakespeare. Okay. And I like this file because, first off, Bill wrote a lot of stuff in his life. We download this file over here, this plain text file. It's 5.5 megabytes. Okay? That's a lot of text over here. A lot of it. It's not even done loading. So 5.5 megabytes, you think to yourself, that's not a lot of stuff. But it's actually a lot for anything that's trying to render text, like this program, like my web browser over here. It's actually not that. For a lot of programs, just will actually squeal and beg for mercy if you try to, if you're basically trying to do a large text file. So let's go ahead and download this, and because it's a fairly large, piece of English literature over here. Let's see. So, actually, I'll download this for right now, but I've also got another idea here that should be even more interesting if I can get a copy of it. So, I'm just going to call this Shakespeare.txt. Oh, turns out I already have it, but I'm going to go ahead and store it in ITP. So, Shakespeare.txt, save it. Okay. The other one I want to look for is Gadsby. Not the Great Gatsby, but Gadsby. So this is a interesting novel that I talk about in data structures. I'll mention briefly. Gadsby, a story of 50,000 words without using the letter E. So it is the most common, so E again is the most common this is an example of what we call constrained writing. So this is a novel that doesn't use E at all. 5 times more than, I don't know than what it was about to say, but it's used a lot. So here's like how it goes. If youth throughout all history had a champion to stand up for it, to show a doubting world that a child can think and possibly do it practically, you wouldn't constantly run across folks today who claim that a child don't know anything. So this is an example of constrained writing. So what I'd like to figure out is what are the character counts for this document without E. So that's what we'll also do with the writing. So we'll do this, and then we'll also get into other fun things like Mad Libs. But I've got 14 minutes left, so I'll start out with the Shakespeare because that's easier to work with. Less complicated stuff. Okay? So now I'm going to use Shakespeare to introduce a new data structure. So we've learned about a couple of different data structures so far. We've got the list, right, and strings, right? Lists hold together a bunch of stuff. Strings hold together a bunch of letters. What I'm going to introduce you to is something called the dictionary, which is not the dictionary file we've been dealing with. Depending on the programming language you're dealing with, the dictionary has a bunch of names. In Python, it's called a dictionary or a dict. In other languages, it's called an associative array. In Java, it's called a hash map or a hash table. In fact, it's built off of something called a hash table. Now, these dictionaries are these powerful, interesting data structures that basically have 3 purposes. Key value storage, which is a bit abstract, but basically it would be saying like, this is the Pokemon number, and here's all the stats about the Pokemon, right? Given this Pokemon number or this Pokemon name, give me all the interesting about all this stuff about that Pokemon. Or given this customer's ID, or given this student's student ID, give me all their class information, their grades, their name, their address, all that stuff, right? When it comes to the other things that dictionaries are used for are two other things: counting and categorizing. So what we're going to use this for is counting arbitrary things, because it makes our job a heck of a lot easier. But we'll probably get there not today. So let me open up Project Gutenberg. It's a very large, not Gatsby, but the Shakespeare file. It's a very large file. And we're going to go through and we're going to just look for we're going to count. What I'm going to do here is we're going to try our best to count how many words are in it. Our best. Because some of these words are, don't really count, I guess, because like 2. But we're going to go through as best we can. Let's go ahead and try this. So first thing we have to do is read this file. Again, I'm going to show it to you again how to read a file because this is the most important thing. Because next week, our homework is actually going to be the hurricane tracker. And all you really need for that is turtles and the ability to read a file. Let's see. So let's go ahead and do Classroom, ITP. Reading shake.py. Here we go. Open. So, or rather, text is equal to open. Give it the file name, shakespeare.txt. And by the way, if you're working with an IDE, like PyCharm or something like that, it's a bit trickier to figure out how to read into text files, but you can come to office hours and I'll help with that. But so open it as read only. And again, for line in text, what can we do? We will just simply go print line. And when I'm working in the terminal as opposed to idle, it goes a lot faster, by the way, as you can see. also worthwhile to note, right, so let's print line.strip so we don't print out as many blank spaces. And then something I want to show you, just kind of to show you, print done, and then print really done. Okay? Now you might think we can't see that done, but, so we're going to print through this, print everything here, done, really done. So, so it only went through it once. And this is because what is text? Text is what we call a stream. So let me go ahead and just show you guys by commenting this out. Print text, this isn't a giant string. This is a stream. It's some kind of object. IO wrapper, name, Shakespeare, mode, read, encoding, UTF-8, which is an encoding for Unicode. Basically, almost everything's UTF-8 these days. So let's go ahead and go through this again. So we are going to read this file, read this file. So go again, it's just going to go through it again, and it'll only go through it once. It closes the file once it's done. So you can only go through it once, so be sure you get what you need from it. If we need to store it, and we want to go through it, then if we want to store this in, like, you know, actual text, then what we can, or you know, we can do text to string, or I might actually call this data, and then text is equal to empty string. So if you want to go through it again, the only way you really can do that is by adding that line into text. Or sorry, for line in data over here, add it to the string. And then we've got it stored in a string, so now we can do whatever the heck we want with it. Right, and now we're just, that's all stored in one giant string. And so now we can print it out. Which is pretty nice. And kind of useful. But let's continue on. For line in text. So what's interesting an interesting thing we can do, by the way, is line. Let's see, can I just get the first 100 lines? Can I slice this? Does that work? I don't know. I'm hoping it does. No, it does not. But I bet you this does. Text is equal to str. I'm guessing this might. Str data. Would that work? I'm pretty sure I know what will work, by the way. I'm just throwing a bunch of things in there and seeing what would happen. Because I'm just curious. The nice thing about... Oh, it's just simply prints out the encoding, which isn't useful. So what we can do, though, is we can do this. We can do text. We can do data.read. That will store the everything inside. Basically, that will turn the file into a string. And then we can print. So, and then if we print text. So this reads a file all in one go. That makes sense to everybody? This reads a file in one go. And it stores in a string, which means we can use it a bunch of times. Another thing we can do, read lines. And what that will do, okay, I guess maybe read lines. Like that. Yep. Oh, that's interesting. What in the world, right? Well, actually, it printed out a list of strings. So now that's actually pretty good for us. So let's go ahead and just simply print So 4-line in text. And just the first 100 lines we're going to print out. Print line. So here we can print out the first 100 lines of text. And what it does is that it stores each line as a string. So this is a list of strings now. When you use read, read reads it all in one go. Read lines reads it all in one go, but rather than storing it in a string, it stores in a list of strings. And those are useful for manipulating it. But most of the time, you can just simply go through the file directly, right? 4-line in the file, and then read it out like that. So on Monday, I will release the Hurricane Tracker homework. And it's a very exciting thing because really it's going to put everything together. Loops, turtles, and file reading. File reading isn't that hard, so we'll go and it will be a lot of fun. All right.